All right, here's a free response question from 2017, a no calculator question from the Calculus AB test. And this is a table problem, very common type of problem on the AP test. Is a table problem where we get our information about a function and its derivatives from a table. So let's look at this real quickly here. So we've got a function, f of x, and it's defined as an equation, okay? So you've got f of x as an equation. We've got g of x here as a table, and its derivative is a table. We've got a graph of h, or h of x, as a graph. So we have three different representations for three different functions, okay? G is a differentiable function, we're told, there, and the table gives us that value. H is a graph. It's piecewise linear. All right. So the question writer is obviously looking for us to be able to use these different representations. That's what we're trying to demonstrate here. So we want the slope of the tangent line of the graph of f. Okay, f is an equation. And so tangent line, right away we should be thinking derivative, right? So we need f prime of x. So we're showing that we know how to do the derivative. So we got two parts, find the derivative of both parts, doing some chain rule. Derivative of the inside is 2. Derivative of cosine is negative sine. Okay, so we're going to find the derivative of the outside and the derivative of the inside. Remember, the inside stays the same when you take the derivative there. Another chain rule here. The inside is the exponent, sine x, and then the outside would be the sine of u. The derivative of sine is cosine. So we're going to derivative of the inside times the derivative of the outside of the whole. Derivative of e to the u is e to the u. Okay, that's an s, not a 5. All right, there's our derivative. And then the question is, what is the derivative at x equals pi? All right, well, let's go ahead and figure that out. So we need f prime of pi. And so this would be negative 2 times the sine of 2 pi. And that's going to be 0 plus the cosine of pi. Cosine of pi is negative 1 times e to the sine of pi. All right. And so this is equal to, and let's work it out, we have negative 2 times, the sine of 2 pi is 0, so we have negative 2 times 0. Good idea to write these out. That's a 0. Plus cosine of pi is 1 times e to the 0. E to the 0 is 1, okay? So this is, I'm putting a little cross there. It doesn't look like an O. Okay, so 2 times 0 is 0 plus 1 times 1, which is 1. Actually, we've got a negative here. Cosine of pi is negative 1, so it's a negative 1. So this is a 2-point problem, and we're going to get 1 point for showing this derivative, 1 point for evaluating for pi. All right. Next, we have k. Now, k wasn't one of the described functions here, but k is a composite function of h of f of x. So we're asked to find k prime of pi. Now, when you got this composite and you're asked to find a derivative, what you're being tested on here, or what the test writer is looking for, is we're looking for a chain rule. So k prime of x, if you want to find the derivative of a composite function, well, that means we need the derivative of h of f of x, and the way we find the derivative of that, let me put some brackets right here, is we've got to do the inside first. So that's f prime of x times h prime of f of x. Okay? And so now we have to ask ourselves, which of these can we find? Well, h is a graph up top, right? So h is a graph. So the only way we're going to be able to find h prime, well, it's a slope. So h prime is going to be the slope, and we need to know the slope of f, all right? But we need to know what we're putting in. Where do we want the slope? There's a whole bunch of slopes here. So which slope do we want? Well, we'll come back to that. Okay, f prime we found here, okay? You know what, we don't need to rewrite that out. Let's go ahead and substitute here. Let's put our value in. So what we're looking for is k prime of pi. And so all we're going to do is we're going to take this function here and let's write it out in terms of pi. So this is equal to f of, pi times h prime of f of pi. All right. Now, we know what f prime of pi is. We just figured it out. You don't need to rework that. Okay? It's the same problem. So that's -1 times. Now we have h prime of f of pi. Work from inside out. F of pi. Okay? So that's h prime of, well, what is f of pi? Well, f of pi is, we're going to go put pi into this function up here. It'll be the cosine of 2 pi times e to the sine of pi. I'm going to go ahead and write that out. You could probably skip this. 2 pi plus e to the sine pi. Okay? And so, let's see, what does this come out to be here? Cosine of 2 pi is 1 plus, and the sine pi is 0. So this is e to the 0, so this is 1. So this whole thing is 2. Okay, so let's keep going. Now, you might not see where it's going, but it's important that, when you're working these problems out, just keep moving forward. Say, all right, I don't quite know where this is going, but I could figure the middle out. So that's h prime of, and the middle comes out to be 2. Okay, now you might be saying, I still don't know what to do. Well, now let's look here, all right? We knew how to figure out f prime of pi. We figured out f of pi, that's 2. And so we need h prime of 2. Okay, so now we forget all of this business that we have here, and we got to say, well, how do I find the derivative of h at 2? Well, the derivative of h at 2, if we look at this graph here, h is a graph, so we're going by ones here, so 2 is right here. So h prime of 2 means what's the slope of the tangent line or the slope of the function at this? Well, the slope of this line right here is negative 1/3. Okay? So negative 1/3. So this is -1 times negative 1/3. Which is 1/3. All right, so kind of a different type of problem there, but you might think that the writers are looking for you to show that the chain rule, the product rule, the quotient rule, and so be looking at those, okay? So this is a function inside a function, and that's what the chain rule is all about, is finding the derivative of an inside function times the outside function. Okay, let's keep cruising. We got m of x, all right. Now we have some function g times some function x. Well, we know something about g and h, sorry, up there. We're looking for the product rule. We want to find m prime, okay. So we want to find m prime of 2, so it's probably best, I think, to start looking for the derivative of x. Let's keep this generic, and then we'll come back and throw in the 2. Well, we have a g function times an h function. So this is the derivative of that deal, g of -2x times h of x. All right, this is a product rule. So we have the derivative of the first here. Now, to take the derivative of the first, that is a chain rule, because it's not just g of x, it's g of 2x, negative 2x. So the derivative of the inside is negative 2. Derivative of the outside is the derivative of g of negative 2x. All right? We can't do much more with it because we don't know exactly what g is. We don't have the equation for g, all right? Then we have h of x. Okay, so we're still doing our product rule. So that's derivative of the first times the second, h of x, plus the first g of negative 2x times the derivative of the second, which is h prime of x. All right? Now, there you have it. Okay, now again, we don't know these functions as equations. I know we're really used to using the equations and plugging in equations and actually finding derivatives, but we don't know that. We can only do that when we have an equation. So h is a graph, we'll get the derivative from the slope. G is a table, we'll get the derivative there from the table. So, all right, we have this bit right here. And now we're going to plug in 2. So we've found the derivative as in the best form we can for the moment, all right? So now we want m prime of 2. That was our ultimate goal, right over here. That's the question. So all we're going to do is we're going to take that highlighted thing there, and we're going to plug in 2. So negative 2 times 2, plugging in 2 for x there, times h of 2. You got to keep track of your work here, or you're going to go crazy real fast if you're not already there. Times h prime of 2. Okay? So, all right. What do we do with this? Well, we've got negative 2. Sorry, I got a squeaky table. Hope it's not messing up the recording here. Times g prime of negative 4. All right? So g prime of negative 4 is what that is. So when x is negative 4, what's g prime? It's negative 1. So g prime of negative 4 is negative 1. So we don't have to compute anything. We just got to look it up. Negative 1. All right? So this guy became negative 1. Okay? Times h of 2. Well, how do we find h of 2? Well, we have h as a graph. So here's the graph of h. So this is saying that when x is 2, we have a negative y value here. Now, what is that? Well, we can compute that. This has a slope of negative 1/3. So we're going down 1/3 over 1, down 1/3 over 1, down 1/3 over 1. So this is kind of testing like an algebra 1 concept. So this is going to be negative 2/3. It's down at negative 2/3. All right, so h of 2 is negative 2/3. Good block here. All right, so this guy here became this. Now, plus g of negative 4, not g prime, but g of negative 4. So we want g of negative 2 times 2 is negative 4. So g of negative 4, let's go up to the table. G of negative 4 is 5, okay? G of negative 4 is just plain old 5. Great. And then we've got this guy right here, h prime. Let's continue our highlighting here. So we've got h prime. So this guy became this. And then last but not least, we got h prime here of 2. So that's the slope at 2. And we kind of use that one right up here. It was the slope of the graph. And we found out that the slope at 2 is negative 1/3. All right? So we have negative 1/3. So now we just have some arithmetic. So we have negative 2, we've got positive 2 times negative 2/3, so that would be negative 4/3, plus, and this can be negative 5/3. That looks like negative 9/3 when you add that, and negative 9/3, negative 3. All right, so we got some product rule there, and then getting those derivatives from the table. We got to know, one, are we looking for the derivative or are we looking for the value of the function? We got h prime and we got h. We got g prime and we've got g. So we got to know, are we looking for the value of the function or the derivative, and then how to get it from the table or from the equation or from the graph. All right. One more. Is there a number c on the closed interval so that such that g prime is equal to negative 4? Justify your answer. Okay. So we've got g prime. Now this is the mean value theorem. We need to recognize that right away. This wording, and we're talking about the slope, a derivative here, is mean value theorem, not intermediate value theorem, the mean value theorem. Okay, so we're using the mean value theorem. So we need to find out what g of negative 5 is and g of negative 3. Okay, because we're looking for the average rate of change. Okay, or delta y over delta x, okay, is a nice symbol. You can write average rate of change or delta y over delta x. That's what we're looking for. This is the slope of the tangent line. So we subtract the y values, subtract the x values in the same order. Okay, notice it can be in either order you want. You could have flipped this around, could have been negative 3 and negative 5. But if I go negative 5, negative 3, it's got to be this. It's y2 minus y1 over x2 minus x1. This is the slope of the tangent line, or the average rate of change. And so the bottom here, negative 5 plus 3, that's going to be negative 2. And let's go up to our table here. G of negative 5 and g of negative 3. What do we got? G of negative 5 is 10. G of negative 3 is 2. Okay, negative 10 and 2. Good way to drive, right? Get those hands at 10 and 2. All right. So we have 8 and negative 2, which gives us negative 4. Okay? So we can basically just say by MVT there must be a C. I'm just going to basically copy this down. A C in the interval negative 5, 3, such that G prime of C equals 4, since the average rate of change is negative 4, right? Is negative 4. Oh, I lost a negative there. All right, so that's what the mean value theorem says. All right, so we got an average rate of change of negative 4, so there's an instantaneous rate of change, or the G prime, because the derivative is the instantaneous rate of change, is negative 4. All right, so there you have it, okay? And lots of different stuff going on there. And so really, these free response questions really tie together lots of things that we've learned, all right? And the key is we've got to know how to get the information of the derivative and the value of the function from here. How do we get the value of h and the derivative of h from a graph? How do we get the derivative of f and the value of f from an equation? Okay, and then recognizing those chain rules and the product rule, and we didn't have any quotients. So, all right, there you have it. Keep working hard, you're going to get it. With more practice, you'll start to recognize these things. And you'll be all set to get that 4 or that 5 on that AP test. So keep working hard.